Yeah, so I'm Martinet Lee. I'm a research engineer from Quantstamp. Typically, we do audit work and some development and consulting as well. So we are particularly interested in the security of like the whole Ethereum ecosystem, and in general, like how this blockchain ecosystem.
Hi, everyone. Zero's Artur here, and with me today we have a very exciting guest, Martinet Lee from Quantstamp, one of the leading crypto security firms. And without further ado, I'll let him introduce himself.
Yeah, so I'm Martinet Lee. I'm a research engineer from Quantstamp. So what we typically focus on is like blockchain security. Mainly, we wanted to make sure like the whole Ethereum ecosystem is secure, and also like we want to look at the whole blockchain ecosystem. And recently, we have, since there's a surge of like DeFi projects, then we also like take a look at those and how the DeFi composability kind of affect each other. So those are kind of our main focus.
Yep. Got it. And I understand you're going to be walking us through Quantstamp today.
Walking you through Quantstamp, like generally how.
Sorry, they have a presentation prepared.
Oh.
Do you want to just kick it off? I think you need to just share your screen.
Yeah, we'll do that. Let me 1 second. Okay, can you see the screen?
Yes.
Cool. Yeah, so today I'm mainly going to talk about the nature of immutability in the wake of creatR. And so kind of the overview of this talk is a brief history about our kind of immutability. When we're talking about immutability, like what are we talking about in the blockchain space, right? And then what's the history of this? And then what creatR does, and then how it works. And then some important properties and how that affects our understanding of immutability and some other security related topics. And so before the DAO hack, so it's pretty much very cypherpunk. The attitude is like, well, code is law. And so even if you are hacked, the exploits are there, even if they are huge, they are not going to be reversed because we have the code there and, it should be done, right? So that's kind of the general philosophy right there. But however, like after the DAO and some major hacks, then it was this ideology is kind of tested, right? So we also see this because we did, like as an Ethereum ecosystem, we did sort of a controversial decision and reversed the hack. And there were of course people disagreeing with it, and so there are Ethereum Classic, and because this reversing kind of violates the belief about immutability. However, on the right bottom, I kind of have this box. This is on the consensus level of immutability, right? Because we have to gather all the miners together and then say like, hey, let's do this together, right? So it is actually a very huge effort in order to kind of reverse these hacks, and so immutability is still like a very hard thing to be violated. So it's on the consensus level. However, like after this, like there's still a lot of attacks going on because like Ethereum is getting more and more profitable, and so the Ethereum community, we decided like not to undo, because previously on the DAO that was a very huge one. It was kind of controversial. We don't undo those hacks, and then developers starts to think about, is there maybe a better way? Like we know there could be bugs out there, right? So how can we like just enables us to fix these things? And that's sort of spawned into the proxy pattern. And proxy pattern, they're actually like very different types. There are very like decentralized proxy pattern where the protocol, the developers will maybe propose a new update to the contract, and then it is actually up to the user to decide whether you want to upgrade to. However, this is not the kind of the most convenient way, and it's not like most of the project we see. It's it take a more centralized approach on these things. So it soon became a common practice to have like a contract owner and just has the ability to upgrade smart contracts, right? So as a proxy, and then it just points to a new version, and then the upgrade is done. So of course, and the owner has some other privilege, aside from just upgrading. But upgrading is already a very huge one because you can basically change the whole logic, right? So here, this thing is kind of on the smart contract level. We can see this implication of immutability on the smart contract level. As long as you check the code, then you'll see that, okay, so this developer can actually do anything they want, or like certain things, right? So this is on the smart contract level, and we can do that by checking the code on chain as well. Now, here we have creatR. So creatR is actually not so new. It is included in Constantinople. And it was an new OP code introduced by Vitalik in this EIP 1014. And basically, let's distill like all the technical details like in one sentence. It's like contracts can be deployed to an address. That does not depend on blockchain state. That's all it does, right? So previously, like it's kind of implying that previously how we deploy contract is we do depend on the blockchain state. Like the contract address is dependent on the blockchain state. So let's kind of dive more into it, on a technical standpoint. So this is the old way, right? This is the create OB code. And so when we deploy a contract, it's basically a user sending out a transaction, and in this transaction, of course, it says like, "Hey, I'm using this create OP code," and then within this transaction, it includes the sender address and then the initialize code, init code, right? And the sender address, when miner is mining this, it will execute, and then it sees the sender address. It goes to the storage and retrieves the nonce, and use the nonce and sender address to calculate what's the new address supposed to be. Right. So init code does have nothing to do with the contract address, but the miner will execute the init code, and then eventually it will deploy the real bytecode here, and then maybe modify some storage. So init code, in a way, you can kind of see it as the constructor of the smart contract, and partially it certainly does that, right? So that's the old way. You can see like it depends on this nonce, basically. And so the new way, though, it's we already see like we get rid of the nonce, so it's not dependent on the blockchain state, and then it kind of just makes this sender address and salt and init code all together, and to calculate the contract address, and then he does the miner does the same thing for after execution, then it deployed the real bytecode, such and such. The main takeaway here is that since it is not dependent on the blockchain state anymore, this contract address, actually can be computed before the contract is even deployed. So that's one implication. So let's kind of look at some important properties, or let's say interesting properties. One I already talked, that's kind of the main usage that we have seen so far. So, we can pre-calculate it, and then, so another thing is that to get the same address, init code, like the code that the miner has to execute cannot change. However, there's one catch. So like kind of like a side effect that people haven't really thought about closely before. It was like this contract actually, if the contract can be self-destructed, then it can be redeployed again at the same address. So that's one thing that we know. And so for kind of developers' pitfalls, or like if we don't look at this close enough, we might assume that the same init code, well, it will deploy the same runtime bytecode, but that is actually not the case. And I'll like in high level kind of walk through like why that is the case. But essentially what it does to the user, or like for anyone that uses like these contracts, then it's this. Contract can be redeployed at the same address, but end up having a different runtime bytecode. And that means that sort of is an analogy to an upgrade, right? So you have a program, and then the logic was completely upgraded. And before we were using proxy pattern to achieve this, and right now we can actually do this via OP code. So yeah, that's the implication. And so on high level, this is the part that kind of give us trouble on the immutability, and we'll kind of dive into that later. Yeah, so this is the important part. So even if we have the same initialization code, we can deploy different bytecode, right? So if in the initialization code, like this is a very high level and just an example, like if we say that, you know, like time is before 8, then return 1 bytecode, then the miner would deploy this bytecode 1. And after this time, then it will, you know, deploy bytecode 2. So that means like with this initialization code, then it is possible to deploy 2 different kind of bytecodes on different times. And of course, if you have more complex logic, then, you know, the developers can do whatever they want. Yeah, so from the user's perspective though, like what we typically do is like when we want to interact with the contract, we do check the source on Etherscan, right? Like more cautious one, we do check the source, look at the contract code, and you know, like it looks safe, it's verified. But this thing is right now not safe anymore, because before you look at the code, like, oh, this is not upgradable, it's not following the proxy pattern, right? And then it gets self-destructed, and then another unsafe version, like a totally different bytecode, gets redeployed at the same address, and you know the contract code is no longer safe. So that's kind of the issue from the user's perspective. And by users, I don't only mean like end users, because a user of a protocol can be another project, right? So that's when we consider that, then it kind of rolls into a bigger problem. And so let's kind of see how it looks like on Etherscan. So this is like a, you know, smart contract and verified, and you know, just some. Here we can see the green check, which is verified. That's all good. You cannot really tell from here, like from just one look, then like how it is deployed, right? So it's not clear. And then after a while, this, you know, this contract self-destructed, but later reinitialized. So Etherscan does detect this, but it's after the fact, right? So it's telling you that, hey, like it's reinitialized. And maybe at the time, if it is a malicious actor, then this is possible to kind of exploit. So yeah.
How widespread of a problem is this today?
So the reason, that's actually a very good question, and I was going to bring it up later, but
oh yeah, sure. Go ahead.
No, I can talk about it right now. I think it's a very valid question. So the reason we're talking about this today is that we start to see the use of creatR more and more often. It is not so this problem itself, like tricking user into doing malicious stuff, it's not very, at least we haven't seen it in practice yet, right? But however, there is, because we're an auditing firm and we look at a lot of projects, right? And we start to see the creatR, this technique has been picked up by developers. And that means that this technique is spreading out. And then so the underlying threat is more, has to be known to others. So like creatR is not really new. It's like I don't know, like Constantinople, right? So it's a while ago. But yeah, we would expect this could be a problem. So that's why like we kind of think this is one important thing to talk about it right now. Yeah.
Sorry, go on. Yeah.
Okay. So this is kind of our view of this. Usage of creatR is not detectable on the smart contract level, right? So if you just look at the smart contract, it looks totally fine. You cannot tell just by looking at the deployed code as well. So same. You have to have the transaction records. So you have to look like how it is deployed, how it is, like, was it create or creatR, right? And then there are actually different like nuances, because it's not that you deploy with creatR then you're unsafe. There are cases and there are legitimate use, because we have seen those use cases, and like the original use case was to save gas, all that. It's a very useful thing. So to really determine whether a contract is safe or not, now it kind of suddenly becomes a very high technical barrier, because in the past you can just look at the code and then see like, oh, it's proxy. People can tell you like, yeah, this is a proxy pattern, and all you have to do is just look at that. Like if it is like delegating call to other places, then well, it's probably a proxy pattern, and then it's very easily identifiable compared to creatR. So we kind of see this as another level. It's a EVM level immutability issue, right? And it's so on the smart contract level, we cannot even detect this. By that I mean programmatically, right? So we can like write smart contracts and then maybe detect a proxy pattern has changed its implementation, because it will have a variable there to point to the new implementation. Then we can check that. But however, for creatR, that is not the case. There are some nuances. You can detect whether the code has changed using some OP code. However, that is also not guaranteed, because actually when you redeploy, even if it's the same code, same logic, the whole state is actually reinitialized. So there's some nuances there. So I'm saying there's a higher technical barrier. It's a bit annoying from the user's perspective, right? And so, well, why talk about creatR now? I think we addressed this. It's because we have started to see this technique being picked up after a year. Then we would think that after this is more spread, then it's more likely for malicious people to use this. So yeah. And another kind of good reason to talk about this is that, as we know, like we have DeFi projects right now, and then we're always talking about DeFi composability. Like right now we compose like different projects together and then form another awesome projects. So this is kind of, for developer, creatR is also a bit annoying in the sense that if you're doing DeFi like composability, or in general composing projects, blockchain projects together, and it's kind of stacked like this, how do you know if it's really safe? Like if there is a malicious contract here that is deployed with creatR, and then it has some malicious intention, all you do is like you're actually just integrating project B and C, and then maybe these like integrate with each other, and then project C maybe uses project M, right? So then your awesome project is actually affected by this. So this is pretty hard for the developers. Yeah, so that's one thing that we see why this is issue. And kind of food for thought is like recently there has this this hack related to ERC-777 token, right? And essentially, like, but if we like just look at ERC-777, it's an awesome extension of the original ERC-20. It gives us some new abilities, which in essence, it's like, you know, we allow an execution of smart contract in between the transfers. So in ERC-20, when we do transfer, it's typically just Alice says transfer to Bob, right? And then, you know, ERC-20 just updates the balance. And or like Alice do approve, and then Bob does the transfer from Alice, right? But for ERC-777, it started to get complicated, because when I say like, hey, I would send some funds to Bob, then it actually goes through and invokes Alice's interface smart contract, and then ERC-77 updates the balance, and then it also goes to Bob's interface smart contract. So there are starting to get like more stuff there. And then just imagine if Bob's interface smart contract was actually, he was using someone else's service, right? And then that was actually maliciously deployed with creatR, and then he can, you know, the attacker can kind of redeploy it to maybe steal Bob's fund and all that jazz. So this like these kind of things we see as a possibility as a hack or exploit. And so, yeah, the real problem here kind of becomes like who's responsible for these things, right? So although like we know like these projects are integrated and more dependent, but who is really responsible, right? So from a user standpoint, though, it is pretty I would say it's pretty easy in the sense that, you know, whoever service that I use, like this project will be responsible for the issue, right? So I see like this creatR as an extra burden on developer side, but also on like the security of the whole Ethereum ecosystem, right? So it's one thing that we kind of want to look into. Yep. And yeah, so that's kind of the brief talk. And so, yep.
Thank you so much for that. I have to say, definitely in many parts, sort of on the technical end, for myself, but I'm sure very insightful for the computer science students, and so on. But how does this? How do you see this? So I understand. Did I understand correctly that this is kind of what you from Quantstamp side you see as like a potentially very large upcoming problem that sort of that is better to kind of address now than for it to sort of slowly get to kind of integrated or sort of used in sort of on a more like wider basis.
Correct. And by addressing now, it's not like we can fix the problem, because the OP code is already introduced, and then it is certainly possible to do that, right? So to kind of fix the problem, in a sense, is we have to make the ecosystem or everyone to be aware of there is this property that is sometimes awesome, sometimes can cause problem, right? Like these are the these are kind of the nature of feature. It's a feature, not a bug.
Yeah.
Right.
Well
So
said.
yeah, so you know, we have to make aware of this feature, and so that people would know, and so users would be more aware of this issue, and so they would maybe look closely and demand from the ecosystem, maybe on the user interface, maybe wallet should show that, oh, is the contract that you're interacting with is deployed with creatR, right? Maybe on Etherscan, they would have they can already tell that it's deployed by creatR, but it's not very obvious. Should it become more obvious? Is it better for the user? And from the developer side, then you have to start thinking about like, oh, you have to even care more about how you integrate with other projects, right? Because when you're developing the stuff, you typically, so there are different, levels of cautiousness. Some people only look at the interface and then say like, I integrate with them, don't really look at the code. Then there's some risk there, right? But there are a lot of like good developers who really look at the code and then see like, oh, okay, now I can make sure that this is safe right now. And now I can integrate with this project, right? However, now it adds another complexity where you not only have to look at their code, you have to go to maybe Etherscan and then like figure out like, okay, so because the project is going to be on mainnet and I'm going to integrate with that project on mainnet, I have to check whether that mainnet address was deployed by creatR, and then can it be done, used for some malicious purposes. So it adds another complexity. Yeah.
Got it. And so if I just zoom out a little bit, then like to me it kind of and correct me if I'm wrong, that like to me it kind of seems that like we're at this sort of like place where there's there's like tremendously kind of cool and exciting technology being constantly built, but also it's getting exponentially more complex, and it's sort of this sort of each layer of complexity that gets added. While there's great and useful features, then there's just sort of there's also like a compounding of these like unknowns that are being built into it. How do you feel like on a broader basis, like is the sort of the speed at kind of like mitigating or sort of understanding these risks versus the speed of kind of layering on top?
Yeah, that's a very good question. So in terms of this, I think definitely like new features coming out way faster, right? And people are not really it's impossible for us to gain all the information, learn everything, right? So for example, this creatR, like that's way long ago, but then at the same time, there are so many new things that was introduced during the last year because in Ethereum ecosystem it was just so exciting, right? And so one way I kind of see this is like so there are core developers of an ecosystem, and then there are people who build upon these code, like this protocol, the application people. And then as a security firm, we kind of see both sides. So we look at the standards, right? We look at the standards and how they change over time. So we are aware of the newest things. However, they are not really as important before a lot of people, or we see signs of people picking it up, right? So that's where we kind of like start to feel like, oh, there's a threat. So before that, we'll see like, oh, yes, there's a theoretic threat there, right? That's when people start to show interest and then start to learn about it, then then there will become a real threat. It's getting closer to that. Because from a security standpoint, is also like we see it as like the difficulty of exploiting something, right? And this difficulty also includes like the knowledge spread as well. Yeah.
And I think this is also okay. That's actually a very, very good point, because I think this has also been like a lot of the these sort of, I guess, yeah, the unknown unknowns is that because it's just like if people don't even know that much about this, then there aren't even that many people to have figured out a way to kind of exploit these things, right? So it might seem that everything's great, but it's just actually if it just hasn't sort of been even seen by that many people. But I think like security wise, it's I mean, it's still been like complete sort of like a leapfrog in terms of where we've come from. For example, like I remember in like 2017, like during the ICO bubble, where like most of the smart contracts for the token projects were, each one was like manually written from scratch and had to get separately audited, right? There wasn't even like up until the kind of very end of the bubble, there wasn't even like that many sort of like common standards there. Tell me about sort of so you guys are obviously like very deep in this in the crypto, like especially on the smart contract auditing side. Like, do you have any sort of like exciting or interesting stories to tell about sort of I guess the worst applications of blockchain, or sort of these sorts of where you guys have really helped someone like dodge a bullet before, or like push them away from the train before it really hits, in terms of like finding a very sort of wide gaping hole before someone else, luckily.
Yeah, so there are actually a lot of instances of that, but I would say like in general, sometimes it's like access control, that sort of issue that well, so I don't think that I can talk about the specific, but like,
oh yeah, for sure. I'm not asking you to name names, but
yeah,
I mean, just to sort of like give like
But yeah, there are like instances where we find like any user can burn other people's token, that sort of stuff, or arbitrarily modify some data on the blockchain. That was supposed to be only by maybe the owner of the address or owner of the contract, that sort of thing. And yeah, those kind of thing often appear, actually.
Well, I mean, you mentioned about immutability, that I think a kind of it's a terrible case, but a great example of that is the parody hack, right? Where like seemingly someone who didn't mean to kind of cause this like absolute kind of nightmare for I mean, like destroyed multiple companies from it, right? And but at the same time, like I think there has been sort of a lot of progress being made. But where do you see the sort of the major threats being for, in terms of like smart contracts generally? Is it the sort of like the so you mentioned like access controls, or where do you guys kind of mostly sort of see the kind of, not maybe mistakes being made, but just which end up being the sort of where like the kind of uncovered areas at the like let's say in the last like 6 months, or at the current state of where we are with it, like Ethereum?
Yeah, so there are different ways that I can kind of talk about this issue. So there are like how the vulnerability kind of shows themselves, and there are also from the point of view of the developer's style, right? And most of the time people talk about like how the vulnerability looks like let's say like, for example, the access control that I just mentioned, right? And maybe like user funds can be stolen, all that thing. But we see kind of as a common pattern, it's that it is very common. It's because of the development style. And we see that because we work closely with the developers, and then we see their code, we discuss with them, and then help them sometimes to make sure the deployment is secure, those kind of things, right? So a lot of times, so one basic thing I would say is just to write the test. So there are different levels of tests as well. So there are like unit tests, functional tests, and then end-to-end tests, like really simulating a user story, a user's journey throughout interacting with this protocol, right? And so unfortunately, a lot of times projects, they are very excited on the development, but lack of tests. So sometimes we don't see tests at all. That's one issue. Sometimes we do see tests. So there are like unit tests and simple ones, but then there are, we have actually almost never seen like the very complex one that really walks you through the whole user story. That's kind of the style we adopt internally. So we would have like a very detailed graph and saying that, hey, this user does this thing. And then after we have that planning, then we start to write the test and then test all the scenarios, which includes like the happy path. Like happy path, like basically ensures the protocol is working. Great. And then also the bad path, like let's say some user was trying to, input some bad data, that sort of thing, right? And so that's kind of the core issue, I would say, that is lacking from the development side. And then it sprouts into all sorts of different issues, as you can imagine, because they probably manually tested it, and it typically would seem fine, right? But that is.
But sorry to cut you, but like, what is causing this? Like the lack of like a proper testing culture? Is it that developers are being pushed so much to sort of like to ship as fast as possible, or is it like a lack of kind of an understanding of how big the risk can be, of like how costful this mistake can be? Or
yeah, I think it's a combination of both. Yeah, I think it's a combination of both, because we certainly see a lot of people are rushing through even audits. Like they could come to us and say like, hey, we're gonna launch like maybe sometime, and they already have a definitive launch date because they promised maybe user, those kind of stuff. But like for developers, it is very typical. Like it's kind of drag. Like sometimes it will extend. You'll need more time. But then there's a promise that you need to fulfill. Then that sort of like, creates a lot of pressure on the developer side, and they would like just ship the feature and hoping that the auditing firm can catch it. We do catch a lot of stuff, but at the same time, we see that is actually, rooting from this development style where, there's no test developed, and there is sometimes very few documentation. So whenever like we see like good description documentation, not the business paper, business logic white paper, but like the technical description, then we were like, oh, this is probably secure, because they actually took the time, right? And then it is also more secure in the sense that, as an auditing firm, it's easier for us to understand the whole protocol and then poke it at very different angles, right? Because there are, if we look at the time of auditing, there's some time which is allocated to understanding the protocol, right? And then after that, then we start to poke around and then like try different things. Can I attack with that? Can I exploit this? Will it break? Will it lock? That sort of thing. But then there's this time that the developers can actually help themselves, because this is in the end their projects, right, that is being shipped, right? So yeah.
And I guess like then they also have like cases where like technically, an audit should always have is always going to have some level of findings, right? And then these findings get fixed. But the thing is, these fixes can technically, they should be like retested, right? But as I think crypto communities especially are not known for their sort of general patience, that like teams are so incredibly sort of, I guess, incentivized to not, to sort of, maybe like just cut that last corner there. But in this case, like, it can like end up being something so like, potentially sort of ruining, right? I think we had a couple of days ago, we had a panel where the topic was interoperability and DeFi, and so we had so Kyber and Ren as well as Thorchain, and then Michael from Ren. He also mentioned like what would he wish for the like as an improvement in the space. He said that just like a general kind of an alliance to set standards a bit more widely, so that in terms of like one of their struggles is just this sort of like the lack of robustness in node architecture, for example, in various and sort of various protocols and so on, that like just like things are, everyone is figuring things out on their own a little bit too much. That you know, like each one of these like completely like separate blockchains or projects, it works. But the thing is now, if you try to start like connecting them together, then like, you know, they're like, it's kind of like, you know, you have a chair where like each of the legs is a slightly different height. It's just like, so I thought that was sort of very interesting, but at the same time, he didn't have like a great sort of suggestion either, sort of how this particular alliance could form. But what is your general? I think like another case of like you mentioned, I guess the classic term of it's a feature, not a bug. Is flash loans, right? Like which is, do you think, in your opinion, have flash loans kind of caused more problems than they've solved, or because I think that like especially this year, they like, you know, they've become a. I mean, there's been just some incredibly sort of high profile cases, right?
Yeah. So that's actually a good thing to talk about. So flash loan itself, it's not, you know, like a bug or something, but it can be used to exploit, right? So kind of analogy, like when human in general have more ability on something, then there are mistakes that's going to be made. Right? You know, people are starting to like, there's new technology, or like there's just new things, then we would have mistakes. But at the same time, it gives us greater ability, right? So I still wouldn't say that it's, well, if you maybe cut right now and then see backwards, maybe it has caused more trouble. Because simply the you know, the amount of hack and those kind of things, right? But then if you maybe look at long term, this is actually just a pain when we're growing as a human, right? As a human society, right? We have a feature, but we don't know how to use it. Then it kind of falls and then breaks some stuff. But then we start to learn how to control this. Right. And then we start to know like, what are the design patterns? How do we defend against this? And you know, we have other things. And after a while, after we have all these protection mechanism, and also the education, which is what you guys are doing right now, you know, like popularizing these knowledges is also very important, right? After these are popularized, then this itself, it becomes just a tool, right? Just a very good feature. So yeah, that's kind of our point of view on this thing.
Got it. I think the on the panel when I asked that, then it was the opinion was more or less like very similar as well. It was essentially that like, yeah, at the moment definitely they've caused more problems, but like they're meant to sort of, you know, I just can't wait for us to get through this period or this phase, you know, that when it ceases being a problem, because it does kind of have a theoretical slightly sort of issue with it as well, that like a lot of the incentive structures, because you know, blockchain is all about incentives, that a lot of the sort of like the incentive structures are built with, like, for example, one important assumption that there is a limited amount of capital and that capital has a cost, right? But the thing is, like, flash loans kind of they remove that assumption, and therefore, like, you know, they sort of they can sometimes, yeah, I guess, be, in this case, they have been just used for some very kind of shocking, and then even shocking like returns of funds, and or shocking thefts of funds, and then like returns of them, and so on. But and I know we don't have too much time left, but to the what would your to the couple of thousand students listening, what would your who are thinking about a potential career in blockchain today, what would your sort of general advice or suggestion be to them?
Yeah, so first thing I would say for the students, you know, do not afraid to take risk, but take the risk responsibly. That means by following the best practices, right? So in general, I would say, like, we do our due diligence. Like, from a technical standpoint, we do our due diligence, which is following a certain development style, writing unit tests, and all that stuff. I would say there must be the same thing for all different kinds of profession, right? Like when I'm doing marketing, what are the principles that I should stick to, right? How do I keep my users safe in some sense, right? I think that's the general thing, and you have to particularly stick to that because in general, blockchain community is one of the fastest pacing ecosystem, and that's where it's really easy to break stuff. And so having this kind of mindset is actually very valuable for protecting your user, right? And then also, like in general, since this is a very fast pacing and error, it's very easy to have error. At the same time, I would say, have mercy on other people who have the errors, right? If you look at their best practices, if they are doing and trying their best on those, then I think it is fair. It's pretty fair to say like, hey, they've done their best on these things, right? So I would say it's kind of twofold on the mindset side, and just go, deep into it because it's pretty exciting, like all this fast-paced thing.
Very well put. I'm sure someone will find some great advice from there. But thank you so much for your time, Martinet, from Quantstamp.
Thank you, Artur. Thank you.